Hello everyone and welcome to another Shift Remote. This is the 11th in our 12-part series where we bring together the brightest developers online for you, our wonderful audience across the world. Let us know where you are in the world. Come to that chat. We're going to be using the chat quite a bit throughout this conference as a way to stay connected. There'll also be a Q&A section there where you can find on your screen as a way for you just to get in touch, maybe ask some questions for some of our panelists as we move through today's speakers. We have a wonderful lineup of speakers ready for you all, and my name's Bilal. I'm just going to be your host for this conference. The hashtag for the conference, as I'm sure we know already, those of you who are familiar, you're like family. You know the hashtag is hashtag Shift Remote. Do get involved. Use that hashtag for any social media. Take a photo of yourself wherever you are. With all of that though, before we get started, I would love to say a huge thank you to our sponsors, without whom none of this would have been possible. So a special thanks to Infobip and Raiffeisen Bank, as well as Microsoft, Autodesk, Microblink, Barrage, Azure Idea, ICT Japania, Venica, Pseudocode 5, Ars Futura, Nanobit, Infinium Q, 9dots, Get by Bus, Aspira, Code Anywhere, and Pluggy. Without you, none of this would be possible, so thank you all so much. Before we get going though, I'm going to pass you over to the CEO and founder of Shift Conference and Shift Remote, Ivan Burazin.
And we're back for the second last Shift Remote event. It's been a long year. For everyone, I believe, for the people here, in our team and from you watching us, I'm pretty sure you've had a crazy year and you're all just waiting for it to end. Good thing though, we have two more for you. So some more content for you to take in before you hit some well-deserved R&R. So today we will be talking about DevOps, and I do believe we have some of the best speakers of any of our remotes up until now. I know I say it a lot, but this one I really do mean it. I mean, we have the founder of Kubernetes with us to talk about DevOps. You can't get any better than that. Also, we have my friend Juarez from Microsoft with us, the guys from Red Hat as well, Venature, Barrage. It's just going to be a cool event, so do stay tuned. Also, we have one more event, the last event in the Shift Remote series coming up 2 days from today, so do tune in as well. But if you don't, I do wish you the best in the holiday season, and I hope for a much better 2021 for all of you that stick with us this year. In any case, enjoy the show and all the best.
Thank you, Ivan. And with that, our first speaker, we're talking DevOps, the unexpected journey. He's a Spring enthusiast, infrastructure abuser, and basically a computer geek. Let's welcome Željko Margeta.
Hi, my name is Željko Margeta and welcome to another Shift Remote talk. I'm a Java developer working at Raiffeisen Bank Austria, and today I will be talking about DevOps. I've previously worked at Sberbank Croatia and Infinum and did quite a bit of pipeline setup and optimization in different organizations, and I will share some of my experiences with you. So let's start with what is DevOps. This doesn't seem to be an easy question to answer, since DevOps means something slightly different to everyone. So I pulled this definition from Wikipedia, of course, and it says that DevOps is a set of practices that combine software development and IT operations, and it aims to shorten the system's development lifecycle and provide continuous delivery with high software quality. And I have to admit that I like this definition. It comes really close to my understanding of DevOps as well. For me personally, DevOps is first and foremost a cultural paradigm. It aims to break down the rigid barriers between classic department definitions and put the product first. Since several DevOps aspects came from Agile, it fits real well there as well. So basically it means having tightly wound teams that work together on achieving their ultimate goal, which is delivering features reliably and repeatably. There isn't any black magic here, it's just simply people working together on achieving a common goal. Everything else is just implementation detail. Okay, so that covers the definition. Now for the journey part. People might not really understand what the big deal about DevOps is, because this kind of a setup comes natural when you think about it. But then you have to take into account big corporate settings. Take banks, for example. Banks are, or I should say were, a prime example of compartmentalization and silos. Mostly because rigid regulatory demands, but in my opinion it comes down to the old, we've always done it this way a lot as well. By the way, my partially fictional story will combine real experiences from different banks I worked in, so take it as it is, a story. It's not bound to a single bank. So, departments are conceptually really detached, each having their own strictly defined responsibilities, almost treating each other as different companies within a company. Cooperation in this kind of surroundings can be challenging at times, and things take way longer than required. So for me, the DevOps movement that started reaching banks as well in the last couple of years was something that I could really stand behind and be passionate about. Just to paint the picture a bit better, I will give you a simple example from the times of yore. Let's say you were working on a feature that went through all the testing phases and was now ready for deployment to production. The testing phases, of course, included manual work from another department, but I will concentrate on the deployment procedure for now. So your feature is ready and you want it deployed to production. But things are not that simple. You have to fill a few documents, wait for the next deployment cycle, and once the feature leaves your hands, it's no longer yours. You have no insight to how it's performing in a production environment, no easy access to metrics or logs, and generally it is as if you threw it over a wall and it disappeared into the abyss. That is until a bug is reported, then you fill a few more documents, or if you're lucky, you ask one of your colleagues from the ops department directly, and you get some logs delivered to you. You seem to slowly get the picture, don't you? And the guys on the ops side didn't have it any better either. They got some artifacts, some SQL scripts, etc., and they deployed it manually to production servers. No real insight on what the feature is, what it should do, or what it shouldn't do in the end. If anything was reported wrong, all they can do is forward it to the developer that built the feature and repeat the cycle again. This all led to some tensions. Issues were always not my problem and caused by the other guys. Not a really healthy relationship, to say the least. Put the SEC department in the picture and you get a really nice battlefield. You know, fun for the whole family. Bring your kids, grab a beer. Okay, so now that we got the ugly out of the way, let's move to better times and what DevOps empowered us to do. The things are a lot more project focused now. Teams are built specifically to deliver specific requirements, and silos are for the most part just an ugly memory. Agile has also been deeply incorporated into the culture, not only for software development. So I have to say that banks are now a much more satisfying place to work at, my bank at least. As far as the DevOps story goes, we've come a long way, and I will show you how we've implemented continuous integration and delivery, and also what are some of the gotchas you should be careful about. So we are basically a Java shop, if not including data and ML teams, which are heavy into Python, and most of our modern infrastructure is built on top of Kubernetes. So the continuous integration and delivery pipelines reflect that as well. But the concepts should be generic enough to be implemented for other requirements as well. First thing I would like to draw your attention to is testing. So if you don't fully cover your deployable with automated tests to the point that you're confident enough to deploy every single commit directly to production, just forget about continuous integration and delivery. You will have more problems than you'll be able to solve. These tests include unit tests, integration tests, and acceptance tests, preferably following the test pyramid, writing unit tests for each complement, then testing the integration between components, and then finally performing acceptance and end-to-end tests on any given environment. Another big prerequisite are metrics and logs, And I don't only mean CPU and memory here, I mean real meaningful metrics for your service, including tracing and observability. This is especially true for microservice architectures like the one we are cultivating. If you can't have a good insight into your service on any environment at any given time, just forget about continuous integration and delivery. It's just not worth it. I'm sorry. So, as for the pipeline itself, this is the current setup we have, and it has served us well so far. There are some things we are planning to change, but more on that a bit later. We are using a Git flow branching model, which in a nutshell has a master branch that represents an artifact deployed to production, a developer branch that is the next version of the deployable, and multiple feature branches that hold features that are currently in development and will be ready for integration in the future. The pipeline is pretty standard, as one might expect. Each new feature is built in its own feature branch. Once it's ready for review, a pull request is opened, triggering the build and deployment of the artifact to the development environment. I should mention that we have a couple of predefined environments, dev here being development, SIT being user acceptance tests, where most of the manual testing is still being performed, UAT, which is a kind of a pre-production environment, and of course the production environment itself. Once the code review is finished, the pull request is merged, and the continuous integration part is finished. After this, the artifact is deployed to the remaining environments upon manual approval. The image is being propagated here, not rebuilt again, ensuring that the exact same version is deployed on every environment. So as far as the integration pipeline goes, it also includes code quality checks, as you can see on the picture. As far as the technologies used, we are using Jenkins to orchestrate it all, heavily relying on shared libraries. Then there is Maven that does the actual build and runs JUnit tests. Code quality checks and analysis is performed by SonarQube, and the images are built by Docker. Nothing too revolutionary here, but compared to the good old times, this is a huge step forward. As far as the logs and metrics go, we are using OpenShift OKD, the community OpenShift distribution, which comes with really good support for both out of the box. This includes the EFK stack for logs, Prometheus, Grafana, all the other goodies. Now, as I've already mentioned, we are pretty satisfied with our current setup, but there is always room for improvement. And I believe that this is one of the core concepts in DevOps as well, empowering teams to customize and individualize their operations to fit their requirements. You don't have to, and probably won't do it in the first try. Make a couple of iterations, see what works and what doesn't work for you. Make changes and repeat the whole process. Things change, so you have to embrace the change as well. Make it a part of your process. Having said that, I would like to go through the things that didn't quite work for us perfectly and what we would like to improve upon. The first thing is our heavy reliance on Jenkins. The pipelines are basically predefined and well written in a way that allows for some customization. In my opinion, are too standardized. The basic idea is to decouple the steps that are being performed from the engine that is performing them. This means extracting the functionality into pretty basic shell scripts and having Jenkins, in this case, simply run them in a predefined order. This allows us to relatively painlessly replace Jenkins with something else in the future. The alternatives are plenty, Tecton probably being the best pick given our usage of OpenShift, but in the end it shouldn't really matter. Jenkins is really built on the concept of plugins, so there is some syncing required if you need something that isn't already available. For example, if you want to switch from Maven to Gradle, you have to have the right plugin installed and configured, and all of this requires time and involvement from multiple people. So the idea is to provide a shell script the environment it is expecting using build containers. If, for example, you want to use Gradle, all you need is a build container that contains it, similar for Python projects, Go projects, or whatever. This is just a trivial example, but you get the picture. The second idea is to split the integration and delivery pipelines into separate physical artifacts, the only integration point being the push or tag of an image to a Docker registry. The issue we have with the current setup is that the pipeline can fail for whatever reason after the image is built, and we have no easy way to just rerun the deployment part in isolation. With people being lazy by nature, this unfortunately means pushing bogus commits to the repository just to trigger the pipeline again. Not the best of practices. By integrating the two parts of the pipeline via the image push, we could achieve better decoupling of the requirements and ultimately allowing for the integration and delivery pipelines to use different runners if required. Again, not the reason why we would like to do this, but it can open some interesting possibilities in the future. And that leads us to the last thing that I would like to change. Now, the keen observers among you might have noticed that I just tipped over the fact that we still require the manual testing step that is being performed on the SIT environment. One of the really mind-opening concepts for me was the decoupling of the delivery of a feature and delivery of an artifact. I stumbled upon this idea after watching one of Sam Newland's talks on microservice architectures, or Devops. I can't really remember now. It is a really simple concept which, in my opinion, opens up a lot of room for simplification and optimization. What it basically means is that by using feature flags, you can decouple the delivery of a feature from the delivery of an artifact, meaning that you can and should treat each commit as if it's going to deploy it to production. And it really should be, but we'll come back to that a bit later. This would allow us to switch to a trunk-based development model, replacing Git flow we are using now. Git flow is a good branching model, but in my opinion, it has a few shortcomings that we also stumbled upon. I didn't mention that there is a bug fix version of the pipeline as well that is configured to deploy bug fixes to production, basically sidestepping some of the steps described earlier. This means more moving parts, and moving parts are bad. The more exceptions and special cases you have, the more you have to take care of it in the end. And there comes a point where it all becomes just too complicated to manage. From my experience, the simpler the mental model, the better it is for everyone. But back to the trunk-based development model, I will try to explain it on a simple example, but first a short definition of what it is. Trunk-based development model only has a single long-lived branch. Call it main or master or trunk, it doesn't matter in the end. Every commit to this branch triggers the pipeline, ultimately deploying the artifact to production. It requires a change in thinking from the developers, but simplifies the process a lot if you ask me. Compared to the Git flow model, each new feature starts by first isolating it behind a feature flag, which should be turned off by default. Then work on that feature is continued, merging it into the main branch as often as possible. This allows deploying the features to production, even though the actual feature is not implemented yet. Once the feature is fully finished, it can be enabled on particular environments, being it for the unfortunate manual testing or for real customers in production. The merges to the main branch should happen a couple of times a day, in contrast with Git flow, where a merge is not performed until the feature is finished completely, sometimes taking up to a couple of weeks. If any overlapping work has been performed in the meantime, someone will have a fun time resolving merge conflicts. After it has been enabled in production, the related feature flag should be refactored out and removed. Besides the decoupling of delivery of the feature from the delivery of an artifact, this model also tries to evade the merge conflict hell that ultimately always happens when you have multiple long-lived branches. The idea is to merge to the main branch as often as possible, minimizing the probability and surface area of merge conflicts. This becomes painfully obvious when performing any major refactorings, especially if new features are being built in parallel. And let's face it, this is often the case. Rarely would you get the time to refactor your code and not push out new features. By using feature flags, one can still achieve a good level of isolation and allow for new releases to be performed in parallel. How this would allow us ideally to deploy each change to production, having a true continuous integration, delivery, and deployment pipelines, meaning a feature could be deployed to all environments, but only enabled on some, if needed, or only enabled for a part of our users, utilizing canary and A/B deployments. All this is also possible using Git flow and feature flags as well, but it just isn't as elegant if you ask me. Another issue with Git flow is that development of multiple features in parallel is not possible in our case, or at least requires a lot of synchronization overhead, since each feature must go through every environment by itself, coupling its deployment to the artifact deployment. Another advantage of trunk-based development model is that if you are developing multiple features in parallel and the order of testing is changed or the order of deployment is changed, it doesn't affect you really. You have all the features available, they're in the code. Yeah. They just need to be enabled in a different order. And this should mean changing a Boolean flag in Redis or in your database. A fully online operation that doesn't require pulling the service down. By using trunk-based development and changing the mental model to treating each and every commit as it will be deployed to production gives us more freedom in the end. There is only one version that exists at a given time, the last commit in the repository, so there's no version handling anymore. It also allows for temporal decoupling because all the required code is there. You just have to enable it. This, of course, isn't a free lunch. It requires more caution around the feature flags, having them as short-lived as possible, but the upside is worth it in my opinion. One more thing you might have noticed is me phrasing the sentences as it will be deployed to production. Ideally, this should be the case. Each commit should end up on production. And as Josh Long likes to phrase it, production is my favorite place on the internet. I love production. You should love production. You should go as early and often as possible. Bring the kids, the whole family. The weather is amazing. It's the happiest place on earth. But there are regulatory demands, unfortunately, and this is kind of a gray area. Each deployment must be approved and logged, and can this automated practice be used is still kind of open. But that doesn't mean we can't be ready. Ultimately removing or at least minimizing the manual testing steps as well. So that was my unexpected story about DevOps. I hope you found it interesting, and maybe next year there will be a few more chapters written. So thank you for your time and goodbye.
Thank you, Željko. Now, next up on our lineup is our panel. We're taking a peek behind the curtain, looking at VMware, who reveal why they're all in on modern apps. Joining us is Craig McCluckey, who's the Vice President of Research and Development at VMware, working in the Modern Applications Business Unit. As well as that, we've got Ben Hale, who leads Pivotal's Java Cloud Foundry efforts, including being a founding member of the Cloud Native Build Pack CNCF Sandbox project. Moderating this panel, as ever, let's give a warm welcome to Nikola Pavicic. You're in for a treat, guys. I'll see you again after that.
Welcome everyone to another Shift remote session. The title of this session is A Peek Behind the Curtain. VMware reveals why it's all in on modern apps. VMware is almost synonymous with virtualization. After all, the VM in VMware stands for virtual machines. But the strategy has evolved over the years, from a focus on public cloud to hybrid cloud, and now the world of containerization. This session will pull back the curtain on the reasons for this shift through a candid conversation between Ben Hale, lead Java on cloud platforms at VMware, and Craig McLuckie, founder and CEO of Heptio, which VMware acquired in 2018 and currently a VP there. They will also discuss how the already significant demand placed on app development teams has been increased during the pandemic as organizations look to new business services to adopt customer engagement models, create new revenue opportunities, and serve a more distributed set of employees. Together, Ben and Craig will explain why they believe that delivering these critical business services will require new approaches to teams, tools, processes, and architectures. Welcome, Craig, and welcome, Ben.
Thank you.
Thank you for having.
Great to have you here. So let's start with a very basic kind of personal question for both of you. I mean, we're looking forward to hear from you and hear all the insights on all the questions that we're going to have. But tell us more about how you came here. A brief introduction about yourself, how you got where you are in your professional life at VMware. We can start with Craig, perhaps.
Sure, I'd be happy to kind of introduce myself. So, obviously my name is Craig, and I've been working in the kind of infrastructure technology space for quite some time. The projects that I've worked on that are perhaps most interesting for this group, it really started with my friend Joe and I building Google Compute Engine, which was an interesting exercise of bringing traditional enterprise workloads into the Google data center. We then sort of decided to take a slightly different tack on things and looked at how could we bring patterns that hyperscalers were using to build and manage applications and take that back to enterprise. So we started the Kubernetes project together. I was also responsible for the Cloud Native Computing Foundation, which is a group of organizations that are already working together to collaborate around a lot of these cloud native technologies. I then wanted to kind of engage with enterprises where they were. So I started Heptio, which was an organization that really focused on bridging the gap between open source technologies and organizations that were looking to consume them. And that obviously worked out, reasonably well for me, but it was also clear that there was a lot of additional work to do. So it made sense for me to join forces with VMware, where I'm responsible for product and strategy across MapU. So really thinking through all of these new technologies that apply to not only the infrastructure space, but are increasingly relevant to developers at large.
Thank you, Craig. Ben, the stage is yours, the virtual stage this time.
So I actually come to this from exactly the opposite direction of Craig. I started out as an enterprise application developer where I sort of discovered Spring in its very, very early days before even there was a corporate entity around it. Spring is an open source development framework, and I was so taken by this and realized it was going to be so important for enterprise development going forward that I quit a really safe job and went and became one of the very first employees at the company behind Spring. And so for the last 15 years, my career trajectory has been taking that foundation, what Spring Framework was, what its goal was when it came to enterprise developers, and continuing to deploy that and listening to them and building new things on top of it. So we went from just the Spring Framework to Spring Framework and Spring Data, so we can help you with your data access stuff. But then we started going even higher than that. We said, okay, now that we know how to build a single application, how do multiple applications, multiple microservices connect to one another? And so we started working on Spring Cloud and bringing Spring Cloud to developers. And what I'm really excited about is this latest stage of my career with the advent of the cloud platforms like Cloud Foundry and especially Kubernetes. We get to have a bit of a reset. We get to say, hey, developers, there's this new strata underneath with Kubernetes that all of your enterprises want to use. If we assume that, what changes can we help you make to your application so you focus even less on the stuff you used to about connecting applications together?
Perfect. Thank you. Well, this is a question for both of you, but maybe, Ben, you already touched a little bit upon this. What do you see as being the most disruptive changes in the developers landscape today, overall, except in your experience?
So to sort of continue on from the beginning, there is like this big disruption coming because developers were so used to the work that they were doing, whether it be something like using Netflix OSS, things like that. As Kubernetes comes into play, those applications that they built with certain sets of assumptions that they'd run in virtual machines or on bare metal, that they'd have complete access to all the resources they might need, that the applications would be long-lived, those assumptions fundamentally aren't going to hold in the future. they're going to run into environments where they're going to run in containers. They have access to less of the internet than they used to, things like that. They'll have restrictions on the resources they can use or even the environment that they run in. And so a lot of the work that I do is helping enterprises navigate this, take the applications that they have, and with minimal changes, I don't think we'll ever get to no changes, ensure that those developers and those applications can work in these new kinds of environments.
Thank you, Ben. Obviously, same question for Craig on disruptive changes in the.
Yeah. I think there's two things that I'd like to highlight. The first relates to, and it's a positive disruption in many ways, which is how developers work. And if you think about, like obviously I'm an infrastructure person, right? Like I've always worked on infrastructure technology. So it's kind of cool to have Ben and me in the same room at the same time because I'm a bottoms up infrastructure up person. He's a app down person. But I think the one thing that is fundamentally, changing and has been changing for some time is the way that developers kind of interface with the groups that are responsible for delivering them infrastructure. Obviously, cloud came along and provided this new paradigm where everything was API accessible. So you could provision up pretty much anything you needed at the other end of an API call. And I'm really excited to see that same transition starting to happen, not only in the public cloud, but also in the private cloud, as you start to move from this world of ticket-driven kind of infrastructure operations to API-driven infrastructure operations. And obviously VMware is a big part of that. But the other thing that I think is really important to kind of recognize is that, as Ben mentioned, the destination environment for your application is changing. Historically, you would always think about that as the operating system. I build this application, it runs an operating system. But increasingly, the world is intrinsically distributed, and the destination for that application becomes something like Kubernetes. And Kubernetes serves the purpose of both being a way to kind of manage the operations of your application, but it also effectively becomes an environment for which you're designing your applications. You can start to think about the distributed system patterns that Kubernetes offers up as being important to application development. And you can start to introduce a lot more intelligence around how your application is not just designed to operate, designed to serve its function, but also its operations. So the introduction of things like custom resource definitions, the ability to start to have much more intelligence around how you're programming that application destination environment in near real time, to support your application's needs becomes really interesting.
I see. Perfect. And then, Craig, and I mean, again, you kind of explained this right now, but what do you think is fundamentally changing the world of developers as these disruptions are happening, as you see them happen? And I mean, would you, from the perspective of a developer as well?
Yeah, I think there's a lot of kind of interesting changes that are happening out there in the world. And, if you think about the evolution of the way that systems were built and run, that really is changing up. So, if you think about it from the infrastructure up perspective, which I keep coming back to, it used to be the world of sysadmins, where, folks would individually curate a specific environment. You had release managers. There was a very kind of procedural, human-intensive process to getting applications out into the production environment. And we started to see the world of, Devops starting to emerge, where programmable frameworks like Ansible and Salt and Chef and Puppet started to, fulfill a lot of those functions. And developers were then able to kind of program their applications into that environment, and were ultimately put on the spot to deal with a lot of those kind of back-end operational considerations. Now, the world that we're moving into with this kind of more intrinsically declarative infrastructure that blends the world of application definition and infrastructure definition and allows us to bring a common set of patterns, unlocks a lot of value. And I think that's going to be incredibly important for developers. We talked a little bit earlier about what's changing in the developer ecosystem, but it's also what's changing in the world. And I think the appetite for digital transformation, for the ability for developers to serve the business has never been higher. And so having access to these capabilities that ultimately drive far more efficient development practices enable us to set up more efficient inner loop, meaning the iterative process whereby a developer goes from their IDE into some kind of testing or pre-production environment, and then outer loop, the mechanism that takes that and qualifies those changes and pushes into production environment in a safe and secure way is fundamentally changing. And that's really been unlocked by these infrastructure up motions where Kubernetes becomes this highly deterministic, declarative environment for the delivery of these pieces, but also a lot of the app-down capabilities that Ben is representing as application libraries become more aware of this. And as we're able to set up these systems that enable you to deliver the application into that type of operating context.
And I think as sort of like a more concrete target for this, like over the last 6 to 8 months kind of thing with the pandemic, what we're seeing is development teams who used to be co-located and tightly integrated with one another, that they could talk to their ops teams constantly. They were all in the same time zone and had a lot of very high bandwidth interactions. That's actually been disrupted as everybody starts working from home. They have schedules around their children and things like that. And so a trend that was already happening, sort of this breaking up into these large monolithic development teams down into much more autonomous, smaller teams, is really accelerating. It was already started. We would have probably gotten there in a decade, but it's going to happen much faster now. And the tools like Kubernetes enable those teams without a huge amount of interaction with other people, without a huge amount of interaction with other teams, to have, sort of very high velocity to be able to deliver really good outcomes for their business, but to do it in a much more autonomous way than they otherwise would have.
And so basically the changes, Ben, in the developer runtime environments are basically this that you mentioned right now, or would you add something else? Or
so I think the runtime has absolutely made it better, right? Like having Kubernetes in place. But one of the key things is a lot of the applications that currently exist today, or the frameworks for developing applications, things like Spring or Rails or something, aren't necessarily ready to go here. And so I think what we're going to see over the next couple of months and years is a lot more awareness at the application layer of Kubernetes as a target environment. We like to think of, our application just runs on an operating system inside of a JVM. That's sort of the world that I come from. But it's absolutely untrue. Things like the way that Kubernetes moves configuration into applications, things like the way that health checks are done by Kubernetes, liveness and readiness probes and things like that. We already see in the Spring side of the house the addition of these two application frameworks, so they natively understand these kinds of Kubernetes primitives. And every time we add something like that, it makes application development easier for this new sort of default target platform for all of these application developers.
Perfect. Craig, what should people managing teams in these environments be focused on from your perspective?
Yeah, I mean, I think, obviously there's a very significant kind of human component to what's going on out there right now. But I think, what Ben mentioned is really important. We've historically, had a way of operating that assumed a lot of, kind of implicit communication channels. Like, hey, my development team is co-located with my operations team. Hey, we're able to kind of operate in this type of environment. And so I think that, really focusing on, getting to a point where we have much more intrinsic team atomicity, where a relatively small group of people are effectively decoupled and empowered to deliver a very concrete outcome without a lot of the entanglements that you expect is going to be, really significant. And I think, as we look at this, and as we look at the challenges that organizations are facing as they undergo a lot of these kind of operational changes, almost every development team or every kind of application or line of business team that I interact with is just relentlessly focused on their productivity. Meaning, when you start interfacing with teams at some level, there's the separation of like how much work are you doing that's actually advancing the business. If you think about developers' job as capturing business logic in code, what percentage of your time is spent coding versus what percentage of your time is spent engineering, which is like, setting up those destination environments, figuring out the mechanics of your build pipelines and those necessary but sometimes painful and operationally intricate pieces associated with delivery. And so the advice I would give to managers of these types of environments is to really start understanding and thinking through what does it take, one, to enable more intrinsic atomic delivery of teams so that there's just fewer necessary interactions, and two, what investments can I make now that enable me to more effectively compete in the marketplace by using a lot of these technologies, using these intrinsically programmable infrastructure substrates, using these libraries and kind of runtime capabilities that are becoming more intrinsically harmonized, that just lead to more intrinsically productive outcomes, that lead to effective continuous integration and delivery mechanics, that retain some of the controls that I need, but that really just set up my teams to support the business in a way that's necessary, because every business is under duress right now. Like when I talk to retail organizations, they're trying to figure out what a post-COVID retail world looks like. When I talk to teams that are responsible for manufacturing, there's a lot of manufacturing shifts happening almost at the global scale. When you talk to telecommunications organizations, there's this absolute necessity to roll out 5G capabilities that unlock value for businesses that are dealing with a lot of these transformative challenges. And across every factor of our global economy, we're seeing these disruptive changes. And so setting the teams up now with the right tools, the right approaches, the right methodology to navigate this world, to achieve those levels of productivity that are going to be essential for the business to survive, is absolutely key.
Well, you mentioned a good point. The investments the manager should look at when managing their teams. Would you advise something like what type of investments would those be?
From my side, well, look, I mean, the reality for a lot of organizations is they're going to be under budgetary constraints, right? Like we're certainly seeing a set of compressions on this. And the starting point for a lot of this is, can you inventory out your spend? Like what core technologies are driving your spend in the most sort of direct way? When you start looking at things like relatively traditional middleware technologies, there are some lovely, perfectly great alternatives that are far more affordable and far more operationally viable than what you might be using right now from the traditional middleware segment. Mm-hmm. It's sometimes hard to justify a modernization sort of undertaking, but if you look at it through the lens of consolidation, reduction in spend, reduction in a lot of those licensing fees, really starting to just look at your portfolio, assess what's driving the spend, both from an operations perspective and frankly from a pure licensing perspective, understand what alternatives exist, and set those programs in place that allow you to get the most out of these technologies that are, both, very interesting in terms of driving operating efficiencies, but also in a lot of ways very affordable, because, frankly, these technologies at the infrastructure level are displacing a lot of what was, historically relatively, complex, expensive, difficult to maintain and deliver. And so, starting to think through that world, and obviously it's not going to be a boil the ocean situation where you're going to go and sponsor a massive initiative to tear down, a lot of your core monolithic applications. But you can make some intelligent leverage decisions to generate value, reduce your operating overhead, and consolidate around some of these technologies that just generate efficiencies for you over time.
Yeah, and I think it's up to the engineering staffs on these teams as well to be sympathetic to the same kinds of concerns. I mean, I'm an engineer like everybody else who just absolutely loves the next new technology, loves, setting up development pipelines and stuff like that. But fundamentally, especially today, there's a lot less slack in your company to be able to do that kind of thing. And so it is important for you to sort of have some self-reflection and say, hey, sure, maybe I think that I can, handcraft some sort of environment with Chef or something like that that's significantly better than what I'm running here. But the company actually needs us all to be pulling in the same direction, to have the same kind of view, to work against the same level of abstraction, the same substrate and things like that. And this gives us that ability. And there's definitely an impetus to do it now.
Thank you. Also, maybe Ben, VMware is an interesting company and historically grounded in traditional IT tech, but how is the company you work with right now approaching this and avoiding the so-called innovator's dilemma?
Yeah, it's a really interesting thing, mostly because this is actually the second time I've been through VMware, and so we had a little intermission in the middle where we weren't with them, and it's been like night and day coming back to it. Before, VMware was very much an operations-focused kind of company. Their goal was to deliver vSphere into data centers, and then the things that sort of went along with that. This time round, I think VMware has a very clear understanding that it's application developers that are going to drive the next round of investments, are going to drive a lot of the next set of revenue. And so we see a lot more commitment from the management team and generally up and down all of the layers of the company for us to deliver application targeted outcomes, right? To keep an eye on what does it mean for an application developer to get a product to market. So we see investments in things like Kubernetes. We see investments in, for example, on the operations side, where exactly you can run it with Project Pacific and things like that. But we also see it in the investment into things like the Spring Team or into cloud native build packs, the CNCF project. We have a lot of those kinds of investments at a very high level of abstraction to help you, the application developer, focus on actually getting to market with your products.
Craig, basically the same question, addressing and avoiding the innovator's dilemma at VMware from your perspective.
Well, I think it's sort of interesting, and I'd frame this around, the opportunity for us is really cut across, two areas. Like, one is, a recognition that the world as it stands today is not going to be the world as it exists in 5 years. We're seeing some just, incredibly disruptive changes, writ large. Obviously cloud is becoming an imperative. Like, we have to make, create opportunities to generate value in the cloud. And for me, I think that that's really grounded in a lot of, what we're talking about here in terms of, what does it take to unlock development teams. But increasingly, we're also seeing organizations trying to get their head around things like edge. If you look at the future, some years down the line, I anticipate, and certainly some of the analysts anticipate that around, 75% of the data that's generated and processed will be processed at the edge. And so for us, it's not just about, looking at, some of the kind of short-term disruptive changes that are happening, but also thinking through what the long-term topology looks like. And that just represents an amazing area of opportunity and expansion for the company. And so we're absolutely committed to delivering great value as Ben mentioned, as we start to see application teams become far more dominant in tech-making decisions. But we also have this amazing opportunity to walk the journey with our customers, recognizing that a lot of their existing assets remain on these assets, recognizing that the economics of cloud haven't fully shaken out yet. There's actually a lot of value for relatively predictable, sustainable workloads to be running in a private cloud context. But then also to be able to walk that journey with our customers to unlock the value as the deployment topologies become much more intrinsically complex, to be able to create the supply chains that deliver those software-based outcomes in these increasingly fragmented universes, and make sure that the things that need to be centralized remain centralized. So for me, it's about just understanding the potential here and making sure that, as a company, and this is pretty clear when I talk to folks like Pat Gelsinger, that he sees this value, this new wave of our existence will be grounded in supporting those application teams that are driving decisions, but also creating an opportunity to walk that journey with our customers, making sure that as we introduce these technologies, they're accessible to the organizations that are chartered with driving a specific set of outcomes, that we deliver them new tools and offer them new ways of operating that generate the efficiencies that they have to survive in this new world.
Perfect. Thank you, Craig. We are slowly running out of time, but then at least another question for both of you. There has been significant demand placed on app development teams. When we already talked about the pandemic, and Craig, you mentioned it before, of course, and this has only increased during this pandemic and the current situation as organizations look to new business services to adapt customer engagement models. And Craig, you touched upon it as well. But what is VMware doing to help organizations in those situations? Who wants to take this one first?
Now, let me start with this discussion, right? So I think, step one is, deliver a better set of experiences for application development teams. So, I talked about this a little bit earlier, but I think this is a really important change that has to happen. Agile teams need agile infrastructure. Like, we cannot live in a world where you submit a ticket and wait a certain amount of time, days, weeks, months, for a piece of infrastructure to be delivered to you. So step one is make sure that the class of infrastructure that's being delivered to teams is progressive, not just cloud-like, but actually generationally more advanced than what we're seeing in a lot of the cloud space. So putting Kubernetes into vSphere so that through an API you can just get this pristine upstream aligned environment. Integrating Kubernetes into vSphere so that the complexities of security and resource isolation just become managed for you. And then, in fact, putting Kubernetes in front of vSphere so you can start to think about virtual machines, those assets that you already have. And a lot of these new capabilities being merged together is an important starting point. But it's also about extending the reach out and thinking about what does it take to bring controls into this. As my developers are building applications, how do I avoid exploding out the kind of operational complexity associated with this? How do I centralize those things that need to be centralized? How do I have that control plane? So we're working on delivering that. And then at the end of the day, it's not just about the productivity and the operational posture, but how do we bring the very best capabilities to application teams that are dealing with this? Spring is a staple for a lot of enterprise developers. How do we make that more intrinsically accessible? How do we reduce the complexity of getting applications going? And making sure that the applications that are being built are durable, sustainable, secure, are highly optimized. And that's a big part of the story. How do we bring a rich set of content to developers so that developers aren't going to Docker Hub and picking up something that isn't necessarily secure, doesn't necessarily have a robust operational story behind it? How do we sort of navigate that content problem? And we're doing that with acquisitions like Bitnami, where we're bringing a very rich curated set of open source content that then meets enterprise specific requirements and is has the ability to be maintained in a production context. How do we bring the tools and technologies that support modernization in a more pragmatic way? But also, how do we take that generational step? How do we introduce service meshes into these environments? How do we address the connectivity? How do we introduce API management? If you look at Spring Cloud Gateway as a framework to support microservices API management. So we're doing a lot of work across a lot of different areas. And VMware today is not the VMware that you think we are. We're actually we're making significant and sustainable investments in a lot of new franchises that I think are going to be exciting and relevant to developers in almost every context.
Change.
Absolutely. To sort of jump on top of that, from the application developer perspective, I can't stress enough how much some of the stuff Craig talks about when it comes to unified, centralized management actually is really important to application developers. Like when you're working in these kinds of large organizations, there's always overhead, making sure you can pass security checks, making sure policies are accurate and things like that. And as an application developer, these are really, really difficult and time-consuming things to do. So, sort of taking a more holistic enterprise-wide approach and saying, hey, if we could assume something like Kubernetes under all of your applications, we can write those centralized tools. We can take a lot of the load off developers, or we can make it completely transparent to developers when it's happening. That's like a real win for an application developer. You are still subject to the same kinds of restrictions and controls, but they're less invasive in your everyday life. And so every time we deliver some new product that can do that for people, that can guarantee that network policies, your connections are always MTLS negotiated, that they always are limited to only 2 endpoints. Those kinds of things happening automatically are huge wins for application developers today.
Perfect. Thank you, Ben. Thank you, Craig. I think this was very, very insightful. We learned a lot about changing basically everything from inside of our organization, inside of VMware, but also all the environments and technologies and the infrastructure that you guys talked a lot about it. Thank you. We are running out of time. I had a few extra questions about how would you advise young developers and so on, but maybe we're addressing this another time. Hopefully see you on a live stage next year for Shift Dev. This has been Shift Remote with Craig McCulloughy and Ben Hale. Thank you so much.
Thank you so much for your time.
Thank you.
Thank you to Nicola, Ben and Craig for that. Now remember that you can always get engaged on social media using that hashtag ShiftRemote. We love it when you do. Connect with us in that virtual world. Let us know what you're doing. Take a photo of yourself, why don't you? Now our next speaker speaks and engages with end users regularly in the areas of DevOps, SecOps and app development. He works for Splunk, as a technological advocate and is a regular contributor to industry blogs such as containerjournal.com, devops.com, and sweetcode.io. He's also the host of a podcast called Developers Eating the World. As a bad coder turned technology advocate, Chris understands the challenges and needs of modern engineers, as well as how tech fits into the broader business goals of companies in a demanding high-tech world. Let's welcome Chris Riley.
Hello, everybody. My name is Chris Riley, and thank you for coming and joining my session today. There's a lot of great content here at the conference, and I appreciate you taking the time to come to my session. Also, I want to thank the people who organized the conference. It's a lot of effort. Things are very challenging now, and so I want to appreciate the time they took to put this together. So to begin, I just want to introduce myself. My name is Chris Riley. I am a DevOps and Dev Relations Advocate at Splunk. What does that mean? Well, basically it means that I couldn't make it as a career developer, so I decided that I was going to continue to do what I love, which is engage with developers and engage with development practices. So I started out my career as a .NET developer. Those were the days of waterfall applications. And since then, I have made sure that I keep current on the technology by engaging with practitioners such as yourself and representing practitioners inside of Splunk. You can scan that QR code to get access to my various podcasts, which are 3 now, and my contact information. And I'd love to hear from you. I always love continuing the conversation from events and hearing your thoughts on my session. Today's session is when metrics and logs are not enough and everyone is on call. The foundation of my talk today is all around the fact that application delivery chains, the applications that those delivery chains deliver, wow, that is a tongue twister, are evolving. And it's not going to stop. There's no end in sight in looking at how we architect our applications, how we build those applications, how we test those applications. And one aspect of that is the management plane, how we monitor and make sure that our applications are up and running in production. So we're going to talk about the history of that, or how classic monitoring was done, why it's evolved, and what does that mean for your teams, your technologies, and your processes. The reality is that companies are going to find themselves in various stages of the DevOps and cloud native journey. And you basically have 4 separate stages. You have retain and optimize, this is rack and stack your servers in a data center. You set it, you forget it, and you hope to never touch it. If you do, you usually know exactly where to go because you may even name your servers like back in the day. And it may be a server that once every 2 weeks you get a disk full error and you address it. But then you see organizations moving into the lift and shift phase where they start to take that infrastructure, they virtualize it fully, they move it to a public cloud service, and you basically have the same kind of premise, which is very waterfall, monolithic, set it and forget it infrastructure, but it has some of the benefits of being hosted in the cloud. Now, when we start to talk about refactoring, that's when things change dramatically. So we will use maybe the strangler pattern to take our current infrastructure and our applications, modify them to support and leverage cloud functionality more efficiently, and slowly start to break those applications apart into what is referred to as microservices. So we go from a monolith to a more distributed application. And then some organizations are what we call cloud native, which is born in the cloud, but not just born in the cloud, because there's a lot of legacy applications out there that were written for the cloud. This is very specifically leveraging microservices-based architectures, serverless-based architectures to fully exploit the benefits of cloud services, and modern development practices. Most organizations are going to be in more than one of these phases. And we see that the vast majority of organizations are in lift and shift and refactor for their public web applications, some with applications behind a firewall, which are their private cloud on-prem applications. So the reality is you're not going to be in all of these phases. The challenge is that monitoring this infrastructure is different for what phase that you're in. Not only are the nature of infrastructure changing, the way those applications running on the infrastructure is changing. What classically used to be a premise where you would take your application, you would deploy it to the same server on a monthly, bi-monthly, 6 months, every year basis, you were deploying artifacts to a static piece of infrastructure. It was slow moving, changes were infrequent, and the amount of transaction volume you had with your users was not very high. To a microservices architecture, you have many hosts, they're multi-cloud, each service might have its own stack, and the relationship between those services becomes very elaborate. There's frequent code pushes, the transaction volume is tremendous, but not only on the software layer are you seeing a distributed system, the boundaries between the infrastructure and the applications themselves have changed because now we are actually deploying the infrastructure with the application. So what used to be a static server with artifacts on top of the server running, you start to see application architectures that look like this. This is a typical service map for a what looks to be about 10 to 12 services and the relationship between the services themselves. Now, because of all this change, because of the infrastructure change, because of the change in application architectures, we have to rethink our management plane as well. Now, what does that mean? Well, as we normally talk about DevOps, we usually talk about velocity, application velocity, going fast. The challenge is that velocity is not going to last if we don't create the right guardrails and management tools and practices to support the velocity. Also, in the day where we had monolithic infrastructure and applications, you knew exactly where to go. You could always go to the log, and you always knew where that log was to address. But today, because of the nature of microservices, you don't always know where the problem lies. As we saw in the service map, the API gateway might be the service that throws the alert, but it may not be the source of the issue. A typical operator is not going to know exactly where to go to find the source of that issue. So your management plane, how you monitor your application, has to keep up with that velocity as well. Without doing that, you're not going to be able to sustain it. And the complications that higher application velocity are going to introduce are going to be greater than the benefit that they bring to the organization. Enterprises are embracing this added complexity by adding a practice of observability. They are beefing up this function in this role called SRE, Site Reliability Engineer, and they are reconsidering their ability to have everybody in the organization on call. So let's start with observability and the term observability, first of all. The first question I get when I use the term observability is, isn't it just monitoring? Yes, in a way it is. And if you are a good curmudgeon like me, you'll hear a new industry term, roll your eyes, and kind of disregard it. I did it for DevOps. I used to say that DevOps was just application lifecycle management. Here is how I embrace new terminology. When the term is addressing a unique problem space, first of all. So the problem space here is unique because modern application architectures are not like the application architectures created when the original set of monitoring practices were set forth, where you start with a log. Second of all, that problem space is large enough because enough people are building for the cloud that we need a term to encapsulate it and make it efficient when you're having conversations about it. This is how I decide to embrace a new terminology. And in the case of observability for modern applications, we're there. So that's why the term observability. If you're really trendy, you'll say O11Y or call it OLI or OLI. I won't use either of those unless it's internal when I'm talking with industry peers. But that happens. We weaponize terminology sometimes in the industry, and unfortunately, we all kind of have to deal with it. The bottom line is observability is a new practice and approach to monitoring where we make sure that we can operate the complexity of modern applications. And how does it start? It all starts with the data. So, at its foundation, observability is the data. This includes logs, it includes metrics, but we also add a new type of data called traces and spans. Traces are the transaction from when your user enters your application to when they leave the application. Spans are the amount of time that the user spends, the user's transaction spends in any one given call or service. Observability is also a development and a deployment strategy because as you instrument this technology, the relationship between the code and how you monitor the code has to be closely tied together. It's an approach. So it's a new way of thinking about how we monitor our applications. And finally, it is a set of tools to make it easier. But you'll notice I didn't lead with the tools, even though there's a typo on my slides and everything is number one. I led with the fact that it is a data and a strategy first. Tools are not going to bring observability into your organization. You leverage tools to create lenses on top of that data and facilitate the practice of observability. Organizations are in various stages of their monitoring or their cloud journey and DevOps. And so you're not going to use observability practices for everything. You're probably not going to use it for your on-prem monolithic applications. You're going to leverage observability for your cloud-based applications where infrastructure configuration and code boundaries are blurring. So the relationship between infrastructure and code are tightly coupled, and thus the monitoring needs to blend the two together as well. When logs and metrics are not enough, when you can't just pinpoint that one log where the problem occurred and go there to find the entire stack trace. Instead, you need an approach that will surface to you where the root cause is and then lead you to the log as a final destination if required. When applications are increasingly distributed, and when application components are stateless and ephemeral. You're not modifying the configurations on this infrastructure, you're replacing it fully. Or you have serverless, where these functions live and die in millisecond time and are ephemeral. These are all reasons where you need observability, and traditional monitoring practices are not going to serve you. And the components of that are making sure that you have all of the data. So you have more than just the logs. You have traces and spans. It's real time and scalable. So the practice of observability moves with the application velocity. As you spin up new services, you don't need to reconfigure your monitoring tooling to support those. And you have the data, analytics, machine learning, and intelligence to create lenses on that data. Of course, the reason we do all of this is our customers and to support application velocity, developer efficiency, and keep up with the demands that our users are putting on us to make sure application quality is what they expect. Once we get to the tools observability, we are looking at monitoring tools. So these are the tools that are going to give you the visualizations, help point you in the direction of root cause. Incident response tools, which is a very specific set of tooling to support on call. And finally, open instrumentation. Because as I said before, if you have to reconfigure your monitoring tools every time you launch a new service, and you're shackled by the tools that get data into your monitoring platform, then the tool starts to dictate how you monitor, but that shouldn't be the case. And when we talk about practices, that gets us to SRE, because the SRE functioner role is really observability's best friend. And what does SRE stand for? Well, it stands for Site Reliability Engineer. I prefer to call it Service Reliability Engineer because that's ultimately what we're building. Some organizations will rename their cloud operations function into SRE without changing anything, but really SRE is much more than the classic NOC, the classic operator approach to supporting application. And really, it is all about being customer obsessed. So that's Jonathan. He's one of our SREs. I get to engage with our SREs on a regular basis. And he has taught me a ton about this role and how you should work back from your customer into your monitoring practices versus the other way around, where your infrastructure largely has determined your monitoring practices. And the reason we do this is because to the typical web-based user today, slow is the equivalent of being down. You can't just focus on your infrastructure being down. You have to focus on things like latency as well to make sure that you are delivering the quality of applications that you need for your users so that you don't lose them. I've recently encountered a scenario where I unsubscribed from a remote learning application for my daughters simply because of latency, even though the content very well could have been superior. So the SRE function is about modernizing the NOC. And it's not just new technology to support it, it's changing the practices. The reason we are changing these practices is we need to be able to support shift left. You've heard about this idea of shift left, where developers, more and more responsibility is being moved earlier in the delivery chain. I caught myself by not saying developers necessarily take on that responsibility, because you can't give your developers more work without giving them new tools and practices to support it. And that's really what the SRE function helps do. You can't shift left without the SRE role. Also, it's to keep pace with release velocity, keep pace with customer demands, and embed an operational partner in the development team. While SREs may still be a part of operations, they are peers to the engineering team, and they are there to serve the developers as an operational partner. The roles and the responsibility of the SRE is to create the strategy around metrics. So determining what metrics should be used for services. For example, rate, error, and duration, referred to as RED, is a very common set of metrics for monitoring applications. They also create the strategy for on-call. So your call down list, the time between rotations, how many engineers are on call and what they're on call for, how they receive data during an incident, etc. And you'll notice that I didn't say that they were on call themselves. Like in organizations like Splunk, our SREs are on call for third-party tools and not the services of the application itself. Developers are on call for their code, which is a radical shift. So the SRE is not there necessarily to be on call, but they frame the strategy around it so that it is successful. Along with that, they are stewards of good on-call practices, good monitoring practices. They often are a part of deployment prep. So as you release new services in production, the SRE is the role that helps prepare to get those services into production. They own the on-call tooling. So while they may not necessarily be the ones on call, they are responsible for the maintenance, the uptime, the setup of on-call tools, and they create the team level dashboards. These are the dashboards visible to everybody within the team. So within side of Splunk, we have many SREs for our cloud-based applications. And our SRE team, again, they are the ones who run the incident response, the on-call platform. So they will help the individual engineering teams set up their rotations, their on-call schedules, and set up how they will be alerted, whether they get phone calls at night or emails during the day. Probably not emails at night because that's not going to wake you up, etc. They will also create the dashboards in our observability tool to know at a team level if things are going well or not application wise. So these are going to be your typical green, red, yellow indicators of are things okay. The reason they do the team level dashboards and not necessarily the service level dashboards is everybody should be able to understand the team level dashboards. At the service level, the service owners are going to have unique metrics that are probably going to be more than 3, like you would have in red, that are going to be specific to that service and what the users of that service expect. It is not uncommon to have a service level metrics that are 10 to 15 specific metrics for that service. Additionally, our SREs will work with the engineers as they deploy new services and frequently, via stewardship, reevaluate their approach to supporting and monitoring those services in production. All of this is meant to make sure that when an incident happens, those who are on call have the most possible tools in their toolkit to resolve that incident as quickly as possible. Now let's talk about incidents. I said earlier, incident response and on-call. Sometimes we think of incident response as incident management through a ticketing tool. But because so much happens during an incident, incident response is actually its own process. Its job is to get to the right person at the right place at the right time. And a surprising amount of activity happens in a very short window of time. And that is why the context of observability matters a lot, and the approach to on-call matters a lot. We interviewed several of our customers who went from just using ticketing or the traditional knock approach to incident response, a true incident response strategy. And what we found is that it was anywhere between 20 to 45 minutes for somebody just to acknowledge an incident. They're going to use the spray and pray method where they blast everybody in the organization via an email, hope that somebody picks it up. Or they're going to use lazy mobilization where they reach out to that one person and hope that they're available because that person is the one responsible for fixing everything. Once it's acknowledged, then the remediation begins. So they start to gather information, they start to get other people involved, they do a lot of searching for knowledge base articles to help solve the problem. And then once they find the solution, they have to wait for resolution, all of the services to come back up. And in these customers, we saw between 6 hours, 8 people, and 5 reroutes involved. That's a lot of time. And that is still even pretty fast because I admit that the customers interviewed here were already pretty far along in their DevOps journey. But if you're an e-commerce application, this is unacceptable, you can't even do this because the amount of money being lost in 6 hours is tremendous. So what you're looking for in an incident response tooling and platform is to flatten the curve. And what we've seen here is customers reduce their acknowledgement to less than 2 minutes and remediation and resolution to less than 2 hours and 3 people. Less people involved, less hunting for information, faster acknowledgement because of a good on-call strategy. So this is all to highlight the fact that on-call incident response is different than ticketing in incident management. And it's important to treat it differently because it is the difference between fixing your application issues quickly or really long time to resolution, and potentially increasing the risk of cascading incidents. So, today, what I wanted to talk to you about is the fact that modern application architectures require a new approach to monitoring in order to keep with the complexities added in modern distributed systems and the velocity the application development teams are embracing. The approaches to that is taking an observability approach, which, yes, observability is a practice of monitoring, but it adds a new set of data which traces and spans and changes the strategy of getting alerts. Once you get alerts, those transform into incidents, and you need to consider using an incident response tool driven by an SRE strategy that is customer obsessed and customer focused. So again, thank you for joining my session today. Please reach out to me if you have any questions, you want to continue this conversation, and enjoy the rest of the content at the event.
Thank you, Chris. And with that, we have one more speaker before our break. I hope that you're enjoying the conference so far. And next up, we're talking adding advanced automation to your toolbox. Our speaker is Red Hat's Portfolio Architect Director, who's renowned in the development community as a speaker, lecturer, author, and of all things, a baseball expert. In his current role, he shares his knowledge of Red Hat's open source technologies and cloud computing. Let's welcome Eric Schabel.
Hello and welcome to DevOps Heroes. This session is going to talk about how to add advanced automation to your toolbox as a DevOps member of your organization. My name is Eric D. Schabel, and today's a little bit different. It's going to be part session, part introduction to a workshop, and we're going to get a little bit hands-on in the amount of time that we have. It's a rather short session, so we can't complete the entire workshop, of course, here with you online. But yeah, we're going to get where we can go. As you can see, this is an HTML online slide deck. It's got some navigation tips here, so if you hit the M key for menu, you can see the entire, anywhere in the workshop, anywhere in the slides, you can see sort of a table of contents pop up, just for your information. So the goals today are to discuss a little bit about the DevOps Heroes and introduce this workshop. As you're walking through these slides later, we'll provide at the end a link and you can see exactly where they're at. The workshop goals are to introduce a new tool for your toolbox, right? So you see some of the elements and products and things that we're going to need. Everything's freely available. Everything's going to be provided for you with links and how to use this, and you'll see how easy it is. But the idea is that you're going to add something new that's kind of unexpected, that you wouldn't think is a normal thing that you'd apply to your daily DevOps stuff, and realize how easy it really is and where it applies. So before we get into all that, I'd like to lay groundwork of some of the basics for DevOps. There's many aspects that organizations are using to apply these days, but some of the basic things are, trying to improve our development frequency, faster time to market, lower our failures, and try to recover faster from our failures. And how do you do something like that? I mean, a process automation tool is perfect for this. It captures things in a consistent manner. It applies metrics. It lets you automate the recovery from failures when things crash in a process. There's a lot of stuff you can capture and automate that takes some of the stuff away and the pain away. It's also a very visual tool, which you're going to enjoy working with. So what is the discussion around this stuff and why we're looking at the process automation is because there's some really common guidelines that apply to the DevOps world. And one of them is you concentrate on process above tooling. So you're looking at trying to achieve something above the tooling to make it all cool, right? It's not about the complexity. It's about capturing what is going on in your DevOps world. Automating the complete build of your application environment. We all know about the continuous integration and continuous delivery stuff. This is a small chunk of that, right? This is some of the process automation going to help you capture some of that stuff. being able to automate the testing of your security. So it's really important that you ensure vulnerabilities don't get processed through your automated delivery of your applications out into the production environment. There's no reason why you can't capture that stuff without having to do it by hand. Also, you want to automate the deployment, of course. So all of these things make a process automation tool a really good choice and a really good addition to your toolbox. It's something I stumbled upon after being a developer for years, and pretty much sucked me in with wow. Basically everything is a process. It's kind of my catchphrase. So it's anywhere you see a process, you can apply this stuff. So as we get into what we're going to be doing in this workshop and getting hands-on with this stuff and exploring what it's about, let's take a closer look at the tooling. And you see here that we're focusing on something that Red Hat has called the Process Automation Manager. This is the upstream product. It is available at the development level, so from developers.redhat.com, as you'll see where we get all the components. This is available for you to use in a development environment up to production to explore with what we call a $0 developer subscription. It means you get a download. All you need is log in. You can download and use this as long as it's not in production. There's no production support. So it allows you to explore what this process automation contains. And you see here that it has something called Business Central. That's like the authoring and management component. That gives you a console. It includes components that allow you to create and manipulate and work with data models. You're also allowed to import your existing data models. You have rule authoring, you have process modeling tooling, so you can design your processes in a graphic environment. You have the ability to use decision tables, think of spreadsheets that can be integrated also. You have the ability to create pages and reports and manage your process instances and stuff from this tool and see what's going on. There's quite a bit inside here, and as we walk through each one of these, you're going to see that we're going to go lab by lab, step by step. And when you happen to get to the point where you're doing data modeling, that box will be highlighted red. So at the beginning of that lab, you understand where you're at in this process. I think it's really handy to be able to know, hey, I'm going to do data modeling, that's this component, and then you can see what that's about. The project we're going to be implementing, we need some kind of project. We need some kind of fictional storyline here for our workshop. So something that's rather common in the world out there in quite a few organizations is some processes require that you have 4 eyes principle. So not just one person check-in, but a second person with 2 more eyes takes a look at it. In our case, we're going to say that we're going to take a very small subsection of our DevOps overview process where this organization has a large main process that automates the complete security checking and deployment and whatever of our application deployments through this whole process. We're going to look at a very small part, what we call a sub-process, that automates the testing of a unit code. So ensuring that a very small portion of code that you're pushing gets checked based on our company-wide rules on whether it needs a peer review from a senior developer or something along those lines. So what's that look like? This process is outlining how a job is submitted by a developer. It gets validated. It's going to apply some automated rules. What's really important about being able to do that is that the rules are externalized from the deployed process. That means I can update that aspect of my project without having to redeploy everything else. So the next job that comes through picks up the new rule right away. In this case, we're going to have a very simplistic example rule where we're going to say if whatever job I submitted has more than 50 lines of code, that's going to require a peer review. So it's going to require 2 more eyeballs to look at it from a senior developer. In that case, we'll have a manual task. We're going to create a form for that that'll be automatically generated. There's an inbox for your senior developers that are put into that group of managers or whatever that have to do those reviews. And they can claim these jobs, and they can see them, the data presented from that job for them in the task form that you will create as a user. And they'll be able to edit it and process it and decide whether it passes or fails review. If it fails, it gets logged as a failed review and is sent back to the developer in this case. If it passes, it goes on for automated testing. We're assuming that that is being sent off to the larger processes where security testing might be done, whatever testing you decide to do, and then it'll log it that it's okay for deployment and send it on to be deployed to whatever environment. So we're not even interested whether it's going to test, acceptance, production. The idea here is to kind of catch a simple process flow that you can go through the aspects of designing a data model, designing the process, designing the, adding the details for it, making a basic rule, creating a basic user task and a form for that, and seeing how all this works. And at the end, you'll deploy and run this whole process to get an example of what it feels like. Let's see here. So the rest of this goes along in the way of lab by lab. So you see the first one is about installing. And again, if we go back to that menu, you can see on the left side also, you can see installation, creating a new project and all that. I will walk through these really quickly in the front here, and then the time remaining will decide whether we have the ability to walk through some of this by hand, and I'll show you how this works. So you have installation. You install all those components. In the second one, you're going to start by creating a new project, so our automation project for the DevOps testing. Then we're going to create a data model. You see there the data model is highlighted with red. And then you see we're going to create our guided rule. So it's going to guide us through the process with the data model to generate a rule around the 50 lines of code or more. Then we're going to design our DevOps testing process using the process modeler. So that diagram you saw at the beginning, you're going to create that. And then you're going to add all the background details. So each one of those process steps requires that something's going to happen, right? So it's very important that, for example, if I have a rule, I have to assign the rules to be checked at that step. If I have logging that has to be done, what am I logging and where am I logging it, that kind of thing. So do realize it requires that you put some background into some of that, the process details. And then we're going to create some task forms. So when we want to submit the initial thing at the front, there's going to be a task form to start the process, and there will also be the reviewing task form for the senior developer to look at what the data is and decide whether it's good code or not, if it's over 50 lines of code. And then the very last one, you're going to run it and experience what it looks like to have an instance deployed in the Process Automation Manager. What it is to start an instance and to watch the way it marks going through the instance and all that stuff. And then when you're all done, that will complete the workshop. And you see there at the bottom, I put the URL for you to be able to access this. It's online all the time. It's fully deployed to Storyline. So let's go back and take a quick look here at the installation and see what we're going to do here. If we click on Lab 1, we can go ahead and get started with that. And you see that Lab 1 starts with the installation right away, and it says download and unzip the project. And I'm going to go ahead and take this out of the full screen mode so we can take a look here at downloading the project. You see here I've created a directory called Shift Remote for our session here, and let's go ahead and download and unzip this. And I'm just going to save it to my download directory, and that's the entire project for the workshop. So for the actual tooling, right? So how to install it and what you're going to need and stuff. So let's copy or move the downloads. So that file there, the Red Hat Process Automation Manager install demo, is going to get put here, and we're going to unzip it, and we're going to drop down into that directory. And this is what you get. You get a README with a bunch of instructions. So if you go onto the GitLab organization BPM workshop, you'll be able to find this. You can read the README and stuff. The docs include some images around what this should look like. You can see basically an install an init for BAT, an init for any Unix system. And that means it's going to automatically install everything. And the fun part is you can read the instructions on what you got to download, but I've tried to encapsulate everything in here so you don't have to. For all of us that don't like to read the manual, just start it for your operating system. And it's going to tell you what to do. You're going to see in the workshop itself, it's going to say, hey, we need to download all these products. Once we do that, we're going to prepare them by copying them into the installs directory. So let's assume we're just not interested in doing it into the installs directory here, and we just hit the init script. And I'll make this a little bit bigger. And so what you see here is I'm a bit of a fan for ASCII art, so I have an ASCII art introduction, and you see right away it says, hey, we're not going to have the right stuff, so let's go download that stuff. So here you can go download it. So I've copied that, opened that up in my browser, and let's see here, it's taken me right to the download for this thing. So the thing I needed was the JBoss EAP 7.3.0 zip. If we go down in the list of all the different stuff they offer, 7.30 zip file, just click here to download it. Luckily, I've done all that just to make it a little bit faster, so I'll copy from my downloads file from the EAP directory I had created to install it in the installs directory. And I can do the next one. And this is going to keep poking me for all these different things. And if you're interested, you can look at the installs directory. There's a README file in there. It tells you exactly what you need. And it's the same thing you saw also on that slide there, right? So when we were doing the slides here, it said, hey, you need to have all these different things. You can go download them and they all take you to the same place. So let me just copy all the previously downloaded. I cheated a little bit. It's in the process automation directory I created, and it's got all the 7.9 stuff here. So now you see, oops, now I gotta move it from here to the installs directory. I copied it into the root directory, so there, that's better. So in the installs directory, we now have everything we need. Let's clear the screen, you see where we're at. Let's try it again. And kaboom, now that everything's there, he's really happy. And you see the ASCII art, you see that he's done a few checks for the sources. He's installed them automatically for us here. We've installed the EAP, the automation manager, the key server, and the case management stuff. You see the users that were created. And the reason I try to be really verbose about this stuff is that it's rather exciting to explore this stuff later. People are interested, how do I create a user? How do I do this? How do I set up email task notifications? Things like that. So everything can be found in that support directory in the project. And it finishes up and says, hey, you've installed everything. This is how we're going to start the server. This is where it's going to be done, where I can log into the Business Central console, and these are the passwords that are available. We're going to use the main one, and if you continue back here, you'll see it says, hey, copy everything in there, hit the init script, you see that everything's ready, and when it's completed, start the server. So let's go ahead and do that. Start the server, and while it's doing that, I provided exactly what you're going to see in the workshop of all the different stuff we saw go by. And then it walks you through a little bit of what's in some of these support directory stuff, so some of the configuration details. Now, the Red Hat Process Automation Manager runs on an application server called the JBoss Enterprise Application Platform. It has a standalone XML configuration file. One of the interesting properties is where, as a developer, do I find my Git repository, because everything I'm doing in this project is put into an internal Git repository that can be found and locked into the JBoss bin directory. So inside of that server's directory, you'll find a .nio git. Good to know. Excuse me. You'll be able to check this out with your development environment and also work on the project. The users have been added. You see some of the code around how that works. The properties for those users, that they're available inside the server so that every application, including the Red Hat Process Automation Manager, can use them. And you see that the various servers are available for different roles. We won't go too deep into that. And then the most important one is we have Eric S, and the password is Red Hat PAM 11. And when it's completely started up, you should be able to log into this. And Eric S, and then a Red Hat PAM1 exclamation point, and you're in. And you see that should show you these screens. That's how every lab finishes, but this is what you should see. And luckily enough, we do. So we've completed lab 1. I think we have just a little bit more time to go on to lab 2. So let's do that and create a new project. Now you see here, before we begin, I like to include, just jump to the end and import the project. If you do that, it shows you exactly how to do that and steps to take. It's for people that want to evaluate this whole project without building it from scratch. So you can import it and then explore it on your own. We're not going to do that, of course. We want to do the entire workshop. So he talks about how when you're logged in, what you're seeing, there's a design. You can see that it has the initial MySpace, which is empty. We can go do that. See here, there's nothing here at all. You can go look at the contributors tab, and we can add. So we can go to MySpaces, and you can see the contributors, We can add a contributor. We'll add our Eric S user as a, this is part of lab 2. Okay, it's in there. Excuse me. You see the metrics tab, and then we're going to go back to projects. And if you wanted to import it, you can import the project here like we showed you. And that jump ahead part, we don't want to do that. We want to add a project, advanced configuration options, and you're going to see that here. It's going to show you all these things. Here's how we added the contributors, the metrics, and here we're going to add a new project, expand the advanced options, and then we can fill in everything we see here. So DevOps testing, a DevOps testing project, and we're going to put it in com.redhat.demos.devops, and we'll leave the snapshot, and it's all fine with me. We'll add that. You see here you have in MySpace a DevOps project, and it's completely empty because eventually you're going to start adding assets, and you're going to start with a domain model, and on you go. So as you see, we've added all that. It tells you about the navigation, and back to the projects view. So the lab's completed when you see that. So if we go back to the projects view, we're done with lab 2, and you see it goes on and on and on, and there you go, create the domain model. So if we go all the way here back to the beginning, we can go right down here to the end. So what we've seen is we've gone through the introduction of what a DevOps process automation toolbox could use, and this completes the workshop as far as I'm going to do it today. But once you go on and you continue to create a data model, you're going to create the guided rules, you're going to create a lab 5 a process, complete the process details, create the process task form, and then you're going to run it. And then you'll have a really good idea of what this looks like as far as the introduction to adding process automation to your DevOps toolbox. So I hope you enjoyed this. The URL's right there. Good luck, and hope to speak to you soon.
Thank you, Eric. And with that, that takes us to our break. We've got 5 minutes here. This is your chance to go grab yourselves a coffee, do what you need to do, and we'll be back here in just 5 minutes' time. We'll see you again soon.
Uz Moja RBA mobilno bankarstvo prati stanje svojih računa, plaćaj putem fotonaloga, upravljaj svojim troškovima ili šalji novac svim kontaktima iz mobitela uz ClickPay opciju. A od sada svaku transakciju iznad 300 kuna provedenu kreditnom karticom možeš podijeliti do čak 24 rate. Doživi taj RBA osjećaj. Uz moja RBA mobilno bankarstvo prati stanje svojih računa, plaćaj putem fotonaloga, upravljaj svojim troškovima ili šalji novac svim kontaktima iz mobitela uz ClickPay opciju. A od sada svaku transakciju iznad 300 kuna provedenu kreditnom karticom možeš podijeliti do čak 24 rate. Doživi taj RBA osjećaj. Uz moja RBA mobilno bankarstvo prati stanje svojih računa, plaćaj putem fotonaloga, upravljaj svojim troškovima ili šalji novac svim kontaktima iz mobitela uz ClickPay opciju. A od sada svaku transakciju iznad 300 kuna provedenu kreditnom karticom možeš podijeliti do čak 24 rate. Doživi taj RBA osjećaj.
Welcome back, everyone, after that break. If you can hear my voice, this is your cue to get back in front of your screen because we're going to carry on with the rest of our conference. As ever, please use the hashtag ShiftRemote. Come to the chat. Let us know that you're here. Tell us what you got up to there in that break. It's always good to stay connected in this virtual world. But our next speaker is a platform architect and evangelist working for Autodesk Research. He blogs and tweets about developing with Forge, AutoCAD and other Autodesk technology. Let's welcome Kean Wormsley.
Hello, my name's Kean Wormsley. I'm here to talk to you today about Autodesk's research into digital twins for the architecture, engineering and construction space. So I'm a software architect working for Autodesk Research. You can get me on Twitter or on LinkedIn via @KeanW, and my email address is kean.wormsley@autodesk.com. So a little bit about myself. I have been with Autodesk since 1995. I started back in the UK. For the first 17 or so years with the company, a long time, I was in our developer network team, focused on providing services to external software developers. Then from 2012 to 2016, I was in the AutoCAD team as a software architect, focused on a few of our AutoCAD-based verticals for different vertical markets. And then from 2016 onwards, I've been a software architect in our research group, focused mainly on exploring the possibilities around digital twins, which is what I'll talk to you today, but also about the applications for generative design in the AEC space. So I've moved around the world. I started in the UK, I moved to Switzerland first in '98, then spent some time in the US from 2000 to 2003, moved to India for 2 years in 2003 to 2005, but then since 2006 I've been back in Switzerland in the French-speaking part. Around that time when I moved back, I also started a blog called Through the Interface, which was really focused on developing software with AutoCAD at the time, but since then it's sort of broadened out as my job has changed. So these days I speak mainly or write mainly about using Forge to solve problems with IoT, etc., integrate data from sensors into a 3D context, and then also various things that I'm working on at that time. So a bit about a digital twin. Now this is a particular view of some of the components that typically might be part of a digital twin. So typically we have some sort of 3D representation. It isn't always the case. There are a number of digital twins where they don't worry about 3D at all. But being Autodesk, we tend to be somewhat 3D focused and think about the modeling aspects. Often there's some aspect of control behavior where you can actually control the physical world from the digital world. You'll also have to get feedback data from the real world via sensors or via IoT. And then you may also want to build in some ability to perform simulations based on the data that you have, as well as some tools that allow we humans to sort of understand this data and predict future behavior. So all of these added together make a digital twin. Now, in terms of the research that I've been focused on or working on in my time at Autodesk Research, we tend to focus on the 3D model. It can be something other than BIM, but very often it's building information model of some sort, so created by one of our tools such as Revit. We also work with models from other environments as well. We don't worry about control behavior, but we do take data from building management systems, so building management data as well as IoT sensors, and then we integrate those into the 3D context. But then we also build in additional tools that help contextualize this data, whether it's what we call splash charts, which are really sort of graphs that allow you to zoom into the data very flexibly, or some sort of surface shading where we map this data into a 3D context onto the volume of a room or onto a bridge, etc. Now all of this is really our digital twin at Autodesk, but what we also sometimes think of it as is a systems debugger or a building debugger, because it's really a tool that allows you to go in and debug the built environment. So that's really what I've been working on for my time. The project itself started before I joined Autodesk Research, so back in 2009. This is a desktop version of the original Project Dasher, which allowed you to once again sort of contextualize this sensor data in a 3D context. We could also do things such as look at daylight analyses, understand the impact of sunlight on temperature and energy consumption, etc. Here we have sort of a starburst diagram which allows us to drill in to the energy consumption for a space, whether it's for the whole floor, a particular zone, or even an individual desk. Now, back when I joined research in 2016, we started work on a web-based version of this tool. Now, this is an early project that was actually done originally for the desktop version that I wanted to show inside the web-based version to give you a sense of aspects of the data that were particularly interesting. So when we originally showed this to the customer for this, so this is NASA, we did this project for. This is for their Ames Research Center, their sustainability base in California, which we fitted out with hundreds of sensors into this space. Now, when the scientists at NASA first took a look at this data, one of the things that really stood out for them were that there were two zones which had a very different temperature profile than the rest of this floor. So the first one is in the central space here, and they said immediately, okay, well that's where we have our servers, it's cooled, it's normal that it should behave differently from the rest of this floor. But then there was another area here which also stood out, and they were like, okay, that's interesting. And then one of the people in the room sort of said, yes, well that's because we're performing a glazing study there. So they'd put some ultraviolet reflective film on the windows of that particular corner office or corner room, and it was effectively impacting the temperature profile for that space. So that was something that out of the 3D data they were immediately able to sort of pull, or the way that the sensor data was contextualized in 3D, they were immediately able to get that insight. Whereas if the data had been locked away in various tables inside a database, it would be much more complicated to understand that quickly. So the next project I wanted to talk about was one for Schneider Electric in the south of France, or this is their office in Grenoble in the south of France. So we went ahead and did a project with them where we could take data from a new occupancy sensor of theirs, and you can see the results of the occupancy this visualization with these little sort of purple Playmobil people. But we could overlay that with the heat map for CO2 data and start to gain insights in terms of why a conference room in particular may not be behaving properly. So here you can see, obviously, there's a lot of people in that room, potentially for the size of the room, and it allowed us to explore the data and say, well, is this something that we need to manage via the building management system? Is there something, we could take a look at an individual CO2 sensor, zoom out on that particular data, and say, well, is this something that happens regularly? Can we anticipate when this is going to happen? Is it every day? Is it every week? Is it every month? And start to adjust the system in order to take that into account. So another project, so we'd spent some time on BIM, and we started to think about moving more towards the infrastructure space to see if this was valid for objects such as bridges. And I'll explain the project that inspired this particular one. But this is our office in San Francisco, in Pier 9, one of our offices. It's at Pier 9, and we have a raised pedestrian bridge that links two parts of that office. And we decided to put some sensors on this bridge, so accelerometers, strain gauges, other types of sensor as well. But this would allow us to start to understand the behavior of the bridge and whether, as a piece of smart infrastructure, it could effectively report on its utilization. So here we have a 3D view looking across the bridge, and you can see the various sensors that are on the bridge. But what we were able to do was to combine that with data from security cameras that were placed at either end of the bridge in order to cross-correlate the sensor data from the individual accelerometers, etc., alongside the camera data, which tells us, well, who is walking on the bridge at that time and where they are. So this allowed us to really start to gain insights from the bridge and start to say, well, what are we able to do with this data? Now, this was very interesting, but one of the problems with the data in terms of having access to security footage was that it was not at all anonymized, and we had to take a great deal of care in terms of who would get access to this data. So the next step was to start to work on some computer vision algorithms that would allow us to essentially anonymize this data and to create a pipeline that could take this camera footage and anonymize it via anonymized skeletons. So this is, we were testing this out at a fairly large scale at that point. But once we were able to sort of create this calibrated skeleton data in 3D, we could then map that back into the Forge viewer and inside Project Dasher, so this project that I've been talking about, in order to more effectively visualize people moving around in a 3D space. Now, all of this was driven by this project, so the MX3D project. This is the world's first robotically printed steel footbridge that is due to be installed in Amsterdam within the coming weeks. Now, the original idea for this bridge was that it was a generatively designed bridge which would be essentially printed by robots heading across a canal, perhaps from both sides meeting in the middle. Now, in reality, of course, it wasn't realistic to expect unattended welding robots to perform their job in the busy part of Amsterdam. So, of course, the eventual project was implemented inside a warehouse. And clearly, the design did change, but ultimately, welding robots were used to 3D print parts of the bridge, which were then joined together to form the overall bridge. Now, here's a picture of us jumping up and down on the bridge. This has already been tested with, multiple tons of water as weight in order to test out its performance, so we weren't particularly worried about anything bad happening. But this was just a bit of fun when we were working on the project. Now, our part of the project was to take sensors, place them into the bridge, and then start to collect that data into a time series database, and then be able to display that in 3D. So clearly, as a piece of smart infrastructure, it was important for us to be able to gather this information, but also to give us some confidence that the bridge would perform as expected. Now here you can see, this was from Dutch Design Week in 2018. We collected, a fair amount of video footage of people using the bridge, and this was us verifying, between the video footage and the 3D data inside Project Dasher, whether our computer vision pipeline was functioning properly, and at that point it seems to be working pretty well. Now things have come along a little way since in the last 2 years of that project, since we've been working on this project. Here we've also got a different visualization capability. I mean, the goal ultimately of having this data of people walking across the bridge is for us to be able to understand, well, how does that correlate with the sensor data that we're receiving? So once again, just as we did with the occupancy data and the CO2 sensors, here we're looking at various sensors that have been placed on the bridge. But the ultimate goal then is for us to be able to visualize the skeleton data that are showing the people walking across the bridge with this animated heat map data that sort of shows the people on the bridge at that time. And here we can zoom in. Our pipeline has been upgraded, so now we're able to sort of see genuine 3D skeletons, whereas before it was kind of 2.5D because they were really only 3D in terms of the distance from the camera. They weren't really, they were still in a plane. So this is the kind of visualization we're able to generate now with this project. So moving on from the MX3D project, we've also spent some time working on a project with this building in the outskirts of Zurich, which is the Nest building, and it's a collaboration with EMPA and the ETH Zurich, and they have this is essentially a test base, or the ability, a test environment for modular construction. So a number of these modular units are swapped in and swapped out. There's this one in the center of this very nice image, which shows the urban mining and recycling unit, which actually has the everything inside that unit has either been recycled or is intended to be recycled. So everything has a material passport, which once again at some point we'll be able to also visualize inside Dasher as well, I would hope. Now, if you want to take a look at the 3D model for this building, you can just go along to Dasher360 or Dasher360.com and click on the demo button, and then you will see this exact same model here. And here once again we're sort of going to take a look at the surface shading for a number of different number of different sensor types on different levels. So here we have temperature, CO2 and presence for the first floor, but we're also going to take a look at temperature for the third floor as well. And once these have all been brought up and we decide to sort of hit play on the timeline, we can then sort of double click one of the 2D images or thumbnails in order to bring up the 3D view centrally. But this allows us to really compare different streams of sensor data for different floors of the space, and even to integrate MEP data. So there you can see the red lines in each of the 2D thumbnails is essentially MEP data that's come from the model. So here's another view of some data that's being displayed for this particular building, which sort of gives you a sense of the type of animation we've been able to create based on this rich sensor data that's been stored from this building. The building itself has upwards of 2,000 sensors, so we were really spoiled for choice in terms of the type of data that we could pull across from it into our system. So here's another view quickly, which has just got multiple types of streams of data once again for the first floor. Something to mention which could be quite useful is that we also have the ability to look at the minimum and maximum range, data ranges for data coming off a building. Now you can imagine this as being useful, for example, if you wanted to just visualize the minimum data, and that will only show, it will really, show, or actually the maximum is probably more, minimum. So say you wanted to find out for a whole, period of time, whether anybody was in the space at all. Now if you look at the maximum value for that space. If it's 0, then that means that nobody was in the space during that time period. So this allows you to really go through and pull together a significant amount of data and visualize it in a meaningful way very, very quickly. So here's another project that we did for a company called Kingspan. So it's a customer of ours and a partner of ours. They have a new showcase building called Icon, which is in Ireland, and they have a very rich set of data in their model. In this case, we're taking a look at various layers for the MEP systems, so the mechanical, electrical, and plumbing systems inside this space. We're looking at them in X-ray mode to be able to see them through walls. But we're also, able to take their sensor data and integrate that into a 3D context as well, of course. So this is a visualization where we're really sort of comparing temperature and CO2, humidity and sound for both the first and second floors all at the same time, as well as having this sort of central 3D view onto that data. So if you're interested in taking a look at this capability a little bit more, all of it's been, you can take a look at dasher360.com. As I mentioned, the Nest demo is on this site. Now, there is also some capabilities being built into the Forge viewer that have been inspired by this project. Now, the ability to locate sensors in 3D space with heat maps and a timeline. I'll start off that animation so you can take a look at that. So there you can see as you're hovering over different sensors, there's a bidirectional connection between the sensor list on the right and then the sensors in 3D space. You can also sort of zoom in on a particular area and start to take a look at the animated heat maps, just as we did inside Project Dasher. So this is going into beta. It's going to be available for Forge developers to check out before too long. You can take a look now at Hyperion.autodesk.io, where you can click on the Contact Us link and fill out your information in order to be informed about the availability of this new extension. If you're new to Forge and you're interested in learning on some more about how we built Project Dasher using Forge, then take a look at forge.autodesk.com as well as learnforge.autodesk.io. But you can also visit my blog, keynw.com, and if you go to /IoT, then you'll get all the posts that relate to this particular project. Now, just to contextualize this a little bit further, why are we interested in IoT? Well, of course, it's important for our customers to be able to manage their operations. That is one thing that we expect these tools to be valuable for owners and operators of buildings over time. But there's also an aspect of this data that is being captured and monitoring the built environment that can then be fed back into the design process. So we invest heavily in technology related to generative design that makes use of sort of AI-centric algorithms and approaches to influence the design process, and that's a combination of machine learning but also genetic algorithms to help effectively explore the solution space for a particular design problem. Well, increasingly we want to bring the data from the real world performance into that process in order to make sure that our designs are meeting the needs of the real world, and that could be making sure a building meets the needs of its occupants, the historical view of the occupancy, but it could also be about a bridge such as the one for MX3D, making sure that it was engineered so that it is optimally engineered for the amount of usage that it's going to have and the loads that it's going to have, because clearly the current MX3D bridge, as the first of its kind, is over-engineered, as it should be. But maybe the next iteration, etc., will ultimately, be engineered differently. So that's this overall vision of how IoT data is ultimately going to influence the design process. And with that, that's the end of my presentation. I hope you found it useful. Thank you very much for paying attention, and please get in touch via social media or email if you have any further questions. Okay, thank you very much. Goodbye.
Thank you, Keen. And our next speaker is passionate about technology and loves to break stuff. They fancy the dynamic duo of technology and security. Let's give a warm welcome. We're going to get hands-on here to Ivan Rimak.
name is Ivan, and today we are going to talk about GitLab CI and some advanced configuration of this tool. A little bit about myself. So I have a background in programming, about 8 years of experience. For the past 5 years I'm working with the Barrage from Osijek in Croatia. Over the years I've developed interest with DevOps practices and security. And for the sake of this presentation, I can say that I'm using GitLab CI in production for over 6 years now. So, why did we start to practice DevOps? In beginning, we occasionally performed our tasks, which includes deployment and building and deploying our software. We use some tools. In the beginning, we used GitLab actually only for the versioning part only. But we wanted to routinely perform our daily tasks. So automation was a big part of it to achieve this goal. I want to stress out that automation here is the goal, is not the goal itself. It's the technique to achieve the goal, which is to routinely perform your tasks in your lifecycle. With this, we wanted to drive consistency. We wanted to detect problems early in our software development lifecycle. We wanted to remove friction between development and operations team. And we wanted to increase our buzz factor, which is a minimum number of team members that have to suddenly disappear from a project before the project stall due to lack of competent personnel. So I've chosen basically 3 sections of the configuration. There are many more, but for starters, we will start with some basic pipeline configuration. We will mention something about the which is called directed acyclic graph, parent-child pipelines, multi-project pipelines. For the pipeline component reuse section, I want to mention before and after scripts keywords. Includes templates and extends block. For the last section, we will cover how to control your pipeline through variables and rules block. I want to mention as well that this presentation will assume that you are familiar with GitLab CI, that it will present some advanced concepts and techniques for the active users of the GitLab CI. I want to also stress out that we are not affiliated with GitLab, nor myself. We just love the tool and love to share the knowledge. So this is basic pipeline configuration. We have 3 stages: build, test, and deploy. You can see that test has that stage can have multiple jobs. All jobs in a stage must complete successfully before proceeding to the next stage. Some additional configuration for the with extended options. You can see, for example, on the test stage that test B job has the mark of allow failure true, so the pipeline proceeds even though the job failed. Also, in the deploy stage, the job deployed to dev has mark of when manual. So this waits for somebody to actually click the button in your graphic interface of the GitLab instance or hosted GitLab, and it has to have the right permission. This is pretty much a relatively new feature from the GitLab itself. I think it was mentioned first about a year ago. It has a background in mathematics with graph theory, and if you are familiar with blockchain, you can also relate to that. There are some discussions in that space as well. But in the context of the CI/CD pipeline, it builds the relationships between the jobs that execution is performed in the quickest possible manner, regardless how stages may be set up. This is an example here which has three stages. It has 2 distribution build jobs. In the test, you can see there are separate tests for both distributions, and finally you have a deploy stage where you can push to production your software which is built and tested. And DEG is enabling us to, for example, to finish the Linux or Mac. If Linux finishes first, it will just move to the next stage without waiting for Mac distributions, a distribution build to finish. It's a rather complex topic if you go into the math stuff, but GitLab documentation is really good about this, and it's pretty much straightforward when it comes to explaining the context of the DEG in the GitLab CI. Here is a visualization actually of this feature. So you can see that Linux build and Mac build pipelines are actually completely separate in terms of DEG. Here you can see a little bit more complex pipelines where you can really put your imagination to work and basically build really complex pipeline with your GitLab CI. Next, we will discuss a little bit parent-child pipelines. So for this example, I have selected the monorepo Git repository pattern, which you can see it will run only on changes under the project one folder. It has a trigger keyword, trigger block, where you can see you can include some other pipeline configuration with this GitLab CI YAML file. It doesn't have to be named like this, but you can, it's for the sake of the argument here. With the include keyword, you will include the file, and with this strategy, it means to hold this pipeline until the other pipeline finishes. Multi-project pipelines, so you can include different projects to your. You can include projects from some other Git repositories. So, for example, here in this example, you have a test job, which is a normal job in your pipeline that you build your script with. And the next job, it's sometimes is referred as a bridge job, where you can trigger some other project. You can specify the project and branch, and you can also select strategy, which is here in this example is depend, which will do the same as in the previous example. When it comes to reusing your pipelines, there are really powerful tools in the GitLab CI to achieve this. One of this is the before and after scripts, where you can have your main script under the script keyword, and if you want to run something before and after, you can use keywords, blocks before script and after script, which is pretty much self-explanatory. It will run before and after the main script. You can have as well on the right, you can see the default block, where you can define, for example, before script to do something, and each and every job that you define after, it will have this before script included. You can also include additional files from your repository directly. For this, you can use the include block with a local keyword. They are processed when the CI is parsed, so on GitLab itself, not on a GitLab runner. Local is the default keyword, so if you don't specify anything, it will assume a local. You can also, for the include block, you can use, for example, you can include CI configuration from another project on a GitLab instance. You can specify the project, and you can specify the file to be included. For the remote option, so you can include some remote files from some remote repositories which are not part of your GitLab instance, and here is an example how to do it. So basically it's a remote keyword. And finally, you can extend some templates of the GitLab CI itself. over the years, they really developed a lot of templates that you can reuse and extend with your pipelines. So templates are actually developed by GitLab and comes with the GitLab instance. So there are different types of templates in GitLab. For example, for this particular example, you can see there is Android Fastlane, and Auto Devops template. It's crucial to mention that you include those templates by including this template keyword. You can also hide your templates inside your configuration files. So you can put a dot in front of your job definition, and basically this technique is only used when you want inheritance, and those jobs don't run on their own, so you extend them on other jobs. So in this example here, you can see we have a tests job which is hidden, and there are some configuration for this job. And in the RSpec job downstairs, you can see it extends the specified template above, and it extends the script. It extends the script. It extends the script keyword, and it has a rules block on its own. Basically, if you want to, it will be executed like here like you can see. And the extend blocks means actually to inherit the references block and override the hashes that are listed here. So you can actually it's really powerful to have for example, one master template, and then to extend it toward the specific project needs in your group. So how to control your pipeline? You can define variables in the UI at the project level. So if you go into your GitLab instance, go to your specific project, go to settings, CI/CD, click on CI/CD, go to the variable section and click collapse. You will see some options. So you can add variables here and their respective values. You can extend the values from the group. For example, if your project is part of some larger group, you can define some parent or group variables which are available then for your project here. You can also see that specific variable can be protected and masked. Protected means it's going to run only on protected branches. And masked means that it will be masked during the job output when you are running your pipelines. You can run a pipeline, a single pipeline from the GitLab GUI. If you go to your project, go to the CI/CD section, pipeline section, there is a button there where you can see where you can click on run pipeline. Then you will see this specific window where you can select the branch for which you want to run the pipeline, and you can specify even here some additional variables. For the API usage, you can even pre-populate these keys and values using the URL parameters as specified here in this example. You can also control your pipeline through your configuration file. There is a variable section where you can define all of your environment, not environment, but your variables, and you can then use them as an environment variable here in the script block. There is also a lot of predefined variables which you can leverage when writing your pipeline configurations. It's grown over the years, so it's best to refer the GitLab CI documentation for the latest version. As you can see, there is a lot of variables which are predefined, which you can use in your configuration. So just a little bit recap about the variables, how are they processed. So for some specific run of the pipeline, you can manually set the variables through your UI or in the API request. You can configure them for your project, group, or even instance level for your organization. It's commonly used if you want to achieve some compliance on your development team level or even the organization level. The variables can be inherited from the jobs in previous stages, so you can pass on variables between your jobs. You can also define them in YAML files, like we shown in that example, using the variables block, and you can use a bunch of those predefined variables that we just previously showed. All of these can be processed and used in the CI engine, so your main GitLab server or your CI jobs, so on GitLab runners. This is also relatively new, so you can use the rules block. Before we used only and except blocks. Now you can use if statements in your rules block. So in this particular example, you can see that if a certain variable is equal to some value, then you can then this job will be run, and for this particular example it will echo out this text. These are the references how to use this rules block. So there are clauses, operators, results, and options for the when block. It's best to see some examples for this. Example 1, job 1, you can see you can define pipeline source and run only. So any other value, if you besides defined in the rules section for this CI pipeline source variable, any other value for this will not execute the job because there is no standalone when clause. And for the second job, you can see that the pipeline source variable is set to any value, any valid value other than merge request event or schedule. The job will be executed. Pipeline controls, when the pipelines run. Okay, so these are the events which will trigger the pipeline. So new commit, new branch, new tag manually. You can have scheduled pipelines and you can use API calls. The variable CI pipeline source can help us with what actually triggered the pipeline itself, and here is the list of the possible sources who triggered the pipeline, which really gives you a powerful way to control your pipeline. And yeah, that's about it. For some other extra information that we didn't cover here in this talk, is definitely you can explore the GitLab API, and by that you can really you can leverage the GitLab CLI command line interface tool, which can be found in Python GitLab package. You can also, we didn't cover, but really the auto DevOps feature, you don't have to use it directly with the full auto DevOps feature, but what you can do is actually extend this template and adjust it to your needs. Write your own templates, include the auto DevOps features, and afterwards extend it and really reconfigure it to your needs. We didn't mention job artifacts, where you can actually save some of your work of your jobs and place them as a download option in the graphic user interface. We didn't cover the container registry, which is pretty much the standard how to use the Docker images. Also, there are a lot of language-specific registries such as npm or NuGet if you are doing something with that, and many more. Also, for some performance testing, we didn't show parallel and matrix testing, which you can explore through the GitLab documentation. So basically, you can run in parallel jobs using some matrix architecture, matrix technique to run multiple jobs in parallel. And that's it. That's it from me. Thank you for your attention. I'm happy to answer any questions if you might have. If you don't want to interact now, you can reach out if you have any questions to hello@barrage.net or visit our website at www.barrage.net. That's it. Happy holidays, everyone. Bye.
Thank you, Ivan. Now our next speaker grew up in Germany. Anyone else grew up in Germany? Any other Germans here with us? Let us know they're in that chat. And they've got over 10 years experience in the area of agile software development. Currently, they're the managing director of Venature, and Venature is an Infobit partner and one of the fastest growing Atlassian Platinum Enterprise Solution partners around the globe. Let's welcome Christian Luberick.
Hello everyone and welcome to our presentation today on modern incident management with Opsgenie. My name is Christian and I'm from Venature. Venature was founded in 2016 and Venature is an Infobit partner and one of the fastest growing Atlassian solution partners worldwide. We supply and implement customized solutions for all Atlassian and Infobit products through consultation, distribution, and technical services. Currently, we are located in 3 countries, Germany, Croatia, and Turkey, and we have over 100+ employees. What have we achieved so far? With our big effort as an Atlassian Platinum and Enterprise Solution Partner, we received the Atlassian Partner of the Year award in the category Rising Star EMEA. In addition to that, we are one of the first Infobit partners. With this partnership, we're helping companies in their digital transformation by providing great omnichannel support and increase their customer engagement. So, this is today's topic, Opsgenie. Opsgenie was bought by Atlassian a couple of years ago. Opsgenie is a cloud-based service for dev and ops teams, providing reliable alerts, on-call schedule, management, and escalations. Opsgenie monitors and reports on the entire lifecycle of a ticket, allowing operations personnel to analyze incidents and outages and identify areas for improvement. So this is how a modern IT environment looks like. On the left side, we have the IT development stack and the monitoring tools such as Isinga or Datadog. On the right side, we have our operations team, which is connected through a ticketing system such as Jira Service Management, Zendesk, or Salesforce. Furthermore, you can integrate a direct alert communication through your preferred chat or chat ops tool, such as Slack or MS Teams. So with this, Opsgenie has over 200+ integrations to sync alert data and streamline your workflow. So let's have a look at an example on how to create an alert within Opsgenie. So here we see the view when you open Opsgenie. So on the top you have the menu bar with alerts, incidents, who is on call teams, services, analytics, and settings. And here within the alerts, you usually get to have a direct look within your alerts. So let's start. So you click on the team section, and within the integrations, you add an integration. Or here in our example, it's Jira Service Management. So you copy the API key and jump over to the webhook section within Jira. So you go into the system settings, scroll down, and click on webhooks. So here we create a new webhook. We enter the Opsgenie listener URL and give it a name. Afterwards, we select the trigger. So on issue created, update, and deleted, we want to receive a notification. So this is what we've configured. Now we switch back to Opsgenie. We save this integration for Jira Service Management. And when we click on alerts, there is nothing yet. But when we go into a Jira Service Management project and we create a new ticket, so for example, need help with the computer, click on create. And now when you click on the ticket, you see that the ticket has been created. So when we now switch to Opsgenie and refresh the page, we see that the ticket has been created. And from here, the team can then do some more actions, acknowledge the ticket, close it, or do some further instructions. So with this view, you never miss a critical alert. Opsgenie groups alerts, filters the noise, and notifies you using multiple notification channels. On flexibility to fit any workflow. So here you have the possibility to customize on-call schedules and routing rules to handle alerts differently based on their source and the payload. In the analytics section, you have dynamic reporting and analytics, so where you can gain insights into areas of success and opportunities for improvement in your on-call and alerting processes. So Opsgenie is available as a standalone offering that integrates into any IT or development stack. Or Opsgenie is included in all cloud plans of Jira Service Management, delivering complete ITSM with end-to-end incident management. So Jira Service Management accelerates the flow of information between operations and development teams to respond and restore systems when incidents occur. So Jira Service Management increased the visibility of work across teams, minimize business impact of incidents, and empower responders to resolve issues faster. So thank you. This was the presentation on Opsgenie. If you need further information about Opsgenie and how to use Opsgenie within your company, you can visit our website, venature.net, or contact us or me directly via email. Thank you for your attention and thank you for joining me here at Shift Remote. Stay tuned and enjoy your next sessions.
Thank you, Christian, and I cannot believe it. We are already at the end of our conference with just one more speaker to go. So our final speaker has over 20 years experience in all things IT throughout their career. They're currently working though for Microsoft on the Asia Development Engagement Lead in Ireland, and they're passionate about all things related to blockchain, IoT, cloud native, and the cloud. Let's welcome Juarez Jr.
Hello everyone, my name is Juarez Barbosa Jr. and I'm the Azure Developer Engagement Lead in Microsoft Ireland. Today I want to talk with you about how you can capitalize on the value of Azure Devops with GitHub. Let's get started. Developer velocity. As companies pursue digital strategies, they increasingly need to act like software companies. As we know, productivity is important in the scope of software development projects. This entails enabling developers to use the right tools so they can not only achieve the productivity levels they need, but also collaborate globally and at scale to achieve innovation in a secure fashion. However, developer velocity is not just about speed, but innovation as well, as it will allow companies to achieve tech intensity. McKinsey & Company has conducted a comprehensive review of what it takes for a company to become a technology company and converged on a single holistic metric, Developer Velocity Index or DVI. The hypothesis is that companies with higher developer velocity achieve better business results. Talking about the research approach, it involved deep structured interviews with more than 100 industry experts, supported by a comprehensive survey with 440 large organizations across 12 industries and 9 countries. It then comprised statistical correlation analysis, considering the overall business performance by analyzing several components like financial performance, innovation, customer experience, brand, talent against the various dimensions of DVI. The findings provide a breakdown by business verticals like financial services, retail, and manufacturing, just to cite a few, measured by level of adoption of new technologies and ability to innovate faster and beat competition through innovation-led growth. They also created a developer velocity assessment framework that allows organizations to score their developer velocity. They can compare themselves with similar organizations by comparing several different factors like size and industry, then gain advice on how to improve and get access to partners skilled at accelerating their developer velocity. You can see the difference that great organizations, the ones that have great developer velocity, make. And these result in happier, more productive developers, better apps, and better results as expected. Across industries, companies with higher DV are outperforming in the market as they are growing 4 to 5 times faster than their counterparts. DV has the strongest correlation with innovation. The top companies score 55% higher on innovation compared with bottom performers, measured by their adoption of new technologies and the ability to innovate faster and beat competition through innovation-led growth. Now let's talk about the different strategies and tools in the scope of DevOps that can help you start your IT transformation journey and then accelerate your business results with developer velocity to achieve tech intensity. The main one is to adopt Azure DevOps with GitHub. For those unfamiliar with GitHub, GitHub has built our platform through our experience with millions of developers, thousands of open source communities, thousands of enterprise customers, and hundreds of ISV ecosystem partners. GitHub is the most secure and most scalable platform for software development. GitHub supports all developers from the individual maintainer with free private, public, and private repositories at GitHub. The Azure DevOps and GitHub teams run as a combined engineering team and are now working together to bring new developer tools to our communities and make sure we have a roadmap for both products that aligns with our customer needs. I'm personally really happy about this because it brings my passion for open source and community together with my love to help folks get better at shipping software. And we continue to see massive growth in all areas. Lots of things use Azure DevOps today, and you're going to continue to be able to use it. We're also now building up a full tool set in GitHub. So if you're starting your project in GitHub, you can stay in GitHub. And of course, Visual Studio has the best coding tools anywhere. But we're making our tools easier to use together. So if your team needs a mix of these tools, you can do that more easily. And if you're using other tools, great news. All three products have great extension models. And together, we have the largest developer ecosystem in the world. Thanks to you at home, our engaged users have grown by more than 30% this year across both Azure DevOps and GitHub, which is phenomenal for tools already so heavily used. And we continue to welcome new developers every day, as recently we welcomed our 50 millionth user to GitHub. So let's talk about the takeaways. Microsoft offers the best end-to-end cloud platform, so your developer workforce can remain as productive across the entire development lifecycle while working remotely as they can in traditionally on-site development environments. By leveraging the Microsoft platform with Azure DevOps, GitHub, and Visual Studio, developers can code and collaborate without friction from anywhere and securely ship code from anywhere and monitor how that code is performing. At last, just to remind you, Azure is more invested in security than any other cloud. That's it. Thanks a lot for your attention today.
Thank you, Joares, for this great talk. Let's jump straight into some questions and answers that might be interesting to our audience. How have you seen DevOps help customers achieve their goals, for example?
Oh, yes, that's a very good question, because DevOps is really critical when you consider the IT transformation journey. Customers, for example, where they have massive data center deployments, for example, and they want to move to the cloud, DevOps is normally the very first right step considering this transformation. Because before modernizing and breaking up the monoliths, for example, creating microservices, it's important to modernize the infrastructure and have the right approach and implement things like CI/CD, for example, continuous integration and deployment. So the DevOps is really a critical tool considering this transformation.
Perfect, thank you. And let's take a little bit of a different look. What challenges are mitigated by adopting the modern DevOps process?
Yes, when we talk about modern DevOps, the first thing that we should think about is the adoption of what we call a managed platform like Azure DevOps, because you can use open source projects and components, for example, but they are disparate pulverized ones. So it's good to have a consolidated and well-tested platform, for example, in order to implement this transformation. Because those open source projects, for example, they are really powerful ones, but it's really complex to, I would say, merge them all and manage the entire infrastructure. So with a platform like Azure DevOps, we have many things beyond this, I would say, abstraction of all the complexity, but things like patching, security, for example, the proper management of VMs, for example, IP addresses, all the complexities, they are then hidden from your, I would say, approach to DevOps. So that's the easiest way to, I would say, move fast and implement a very solid DevOps strategy.
Perfect. Thank you. We talked about some of the challenges and how to mitigate them. What are some of the greatest benefits customers can receive when adopting a modern DevOps approach?
Oh yes, I talked a lot about that during my presentation, because at the end of the day, it's what we call the developer velocity and the developer velocity index. There's a joint research by McKinsey and Company and Microsoft. And this developer velocity, it means productivity, with the adoption of the right platforms, like I said, a managed one like Azure DevOps, but also tools with Visual Studio and GitHub, as the code repository, and this combination is really critical because developer velocity means more productivity. And at the end of the day, the companies, they can also save money. So it's all about costs, considering the strategy mid to long term.
Perfect. Thank you for this great insights. Maybe a last question on a less technical issue. You have a vast experience in IT. Do you have an advice for maybe some of our younger audience on how to how to have a career in developer relations and in DevOps that you talked about?
Yes, of course. Yeah, I would say that for those early in career, for example, we should consider first to really understand computing and have a rock solid background, considering all the main disciplines. But nowadays, it's really important to pick a couple of topics, for example, IoT or blockchain or DevOps, for example, because when I started my career 20 years ago, for example, it was easy to master, let's say, the C language. It was about reading the three Ritchie books, for example, Richie's book. But nowadays, for example, in case you decide to explore DevOps, there are many things that you have to master. Like as I said, continuous integration and delivery, the operating systems, cloud native, and also scripting, and so many things. And those things, they are really complex ones. So in order to, I would say, build a solid career and become a very good professional, it's important to have a focus now, and not try to grasp everything.
Perfect. Thank you, George, for a great talk and the Q&A. Our audience enjoyed it, hopefully, and then obviously they can reach out to you via social media if they want to. Thank you once more for being here at Shift Remote.
You are very welcome. It was my pleasure indeed to participate in such a great event. Thank you.
Thank you, Juarez. And with that, that brings us to the end of another Shift Remote. And I'm sure that you enjoyed it. That was the 11th of our 12-part series. We have one more, our final Shift Remote conference there for you this Thursday. So if you haven't registered already, please do. And we look forward to seeing you again then. But with that, I just want to say a huge thank you to you, without whom none of this would be possible. Another thanks to our own team here at Shift. But of course, a massive thank you once again to all of our sponsors at Infobip, Raiffeisenbank, Microsoft, Autodesk, Microblink, Barrage, Azure Idea, ICT, Japania, Venature, Pseudocode 5, Ars Futura, Nanobit, Infinium Q, 9dots, Get by Bus, Aspira, Code Anywhere, and Pluggy. Without you, none of this would be possible. Thank you so much, and I look forward to seeing you again on Thursday for our final Shift Remote. Take care.